So good evening, everyone. Am I audible clearly?
Yes, ma'am.
Yeah. So give me just a second. My Wi-Fi is just connecting and then I'll start the session. Actually, there was a power cut. So give me just few seconds.
Yes, ma'am.
Hello, am I audible? I'm in a meeting, right? I have switched to my Wi-Fi. Hello. Am I audible, friends?
Yes, ma'am.
Yeah.
Yes, ma'am.
Yeah. So I think now I'm starting the session. Give me a second. I'm going to share my screen now. The screen is visible.
Yes, ma'am.
Okay. Fine. So friends, today I'm talking about the ANOVA. I think everyone knows ANOVA stands for? Anyone?
Analysis of covariance.
Analysis of variance.
Analysis of variance, sorry.
It's not covariance, that is ANCOVA.
Yes, ma'am. Analysis of variance.
ANOVA is the analysis of variance, right? So ANOVA is again a kind of parametric test, right? Second thing is, it is the extended form of independent sample t-test. So anyone who can tell me what is independent sample t-test? Yes.
Test having two independent variables which are unrelated to each other.
Yes, ma'am, do you please repeat, Pushpa ma'am?
Ma'am, two independent variables which are not related to each other.
Right, means we have to compare the mean in two independent groups or samples. This is what we are doing in the independent sample t-test, right?
Ma'am,
You're not audible. Ma'am.
you are in mute, ma'am.
Now I'm audible?
Yes, ma'am.
Yeah. So I was telling you, it is very much like independent sample t-test. As I have said, it is an extended form of the independent sample t-test. The meaning is that ANOVA is also comparing the means, right? But when independent sample t-test is also comparing the mean, ANOVA is also comparing the mean. So what is the difference in these two? So difference comes when we talk about the comparison of means in more than two groups, right? So I think we understood this thing yesterday itself, that when we are talking about independent sample t-test, it can compare the mean of two groups. But what if you are having more than two groups? So if you can recall, yesterday I told you, if you are having more than two groups available in your categorical variable, so previously or priorly you need to decide in which two groups you want to compare the means. But if you want to compare all the groups together, in that case, the next choice is ANOVA, right? So if you are having more than two groups available in your categorical variable, in that case, we will go for ANOVA over the independent samples t-test. Is it clear?
Yes, ma'am.
Yes, ma'am.
Right. So we can say here, I will mention one more thing here. That when we want to simultaneously compare, it is very important here. Simultaneously, we are comparing more than two groups. In that case, we are using ANOVA, right? Now, ANOVA, as the name itself saying, it's analysis of variance. That means we want to see the variance in the mean in various groups. What is the variance is coming in the mean in the various groups? That way we can give this particular test a name as ANOVA, that analysis of variance, right? Now, the variable requirement. So I think before taking the variable requirement, I will talk about the types. So types of ANOVA. ANOVA is one way. I think everyone knows this thing. It's one way ANOVA and two-way ANOVA. These are the two varieties or types available under the ANOVA, right? When I talk about one-way ANOVA, one-way ANOVA is again we are using for comparing the means. Here, you need to understand this thing, that the variable requirement will be same as independent samples t-test, right? Meaning is that you need to have one dependent variable, which will be your numeric or continuous variable, and you will be having one IV, which will be your categorical, with more than two groups or samples, right? So this is the variable requirement of one-way ANOVA. So meaning is that it will be only one-way table. So I think yesterday or before that we have discussed the chi-square test, right? So I told you the cross tabulation, that is a two-way table. In case of one-way ANOVA, your table will be only in one way, because you are having only one categorical variable, so that you can list down either in a column or in a row. So your table will be in a one way only. That is why we can call it as a one-way ANOVA. It is also known as omnibus, right? Because of this reason only. Second is the two-way ANOVA. So two-way ANOVA variable requirement will be, you need to have one DV, which will be numeric, and you need to have two IVs, which will be categorical. So this is the variable requirement of two-way ANOVA. In case of one-way ANOVA, you need to only formulate the one hypothesis, that is one null hypothesis. So the nature of the hypothesis will also be same as we are making in the independent samples t-test. That is, there is no significant difference in the mean of DV corresponding to the groups of I. Right? So this is a simple hypothesis which we are using in case of one-way ANOVA. Opposite to this, you can say there is a significant difference in the mean of DV corresponding to the groups of I. I hope it is clear. I hope it is clear, friends.
Yes, ma'am.
Yes, ma'am.
Now, when we come to the two-way ANOVA, so here you can understand two-way ANOVA because you are having two IB, that is two categorical variables. So your table will be two-way, means one variable you are taking in a row, one variable you are taking in a column, likewise, right? So that way, in the corresponding, what I can say, the groups, you will write the value of your DB. So that is two-way ANOVA. And here you need to make, firstly, I think say there is again the types of two-way ANOVA. That is with replication and without replication. So in case of with replication, you need to make total 3 null hypotheses. In case of without replication, you will make total 2 null hypotheses, right? So this is the number of hypotheses you will make in case of two-way ANOVA. Again, repeating, with replication means where you are replicating the categories of your categorical variable, that is known as with replication. Without replication meaning is that you are not replicating the categories of the categorical variable, that is without replication. I think looking at the data which I have provided you, you can understand what is with and what is without. If not, I'll again discuss once I will talk about the two-way ANOVA using the Excel. So this way you can understand this thing, that when you talk about the two-way ANOVA, you need to make total 3 null hypotheses when you are repeating your categories of the categorical variable, but when you are not repeating them, that is a case of without replication, and you need to make only 2 null hypotheses. And I think everyone knows this thing. For every null hypothesis, you will be having one alternative hypothesis. Right? Clear?
Yes, ma'am.
Yes, ma'am.
Now comes, if again, I think, although we are not checking all these things here in the case of Excel, but still I can tell you there are certain assumptions of ANOVA also, which are also very similar to the t-test. That is, you need to check normality, you need to check outliers, you need to check homogeneity of variances. All these things or all these assumptions are very common when we talk about ANOVA and the t-test, right? So these assumptions generally we need to check before performing the ANOVA. Now I'll talk about the what I can say, it's a limitation. What is the limitation of ANOVA? ANOVA is lacking in one thing. What is the lacking? If I will write the null hypothesis, if suppose I am comparing the mean in the 3 groups, right? Okay, so I have written here mu1. So this will be my null hypothesis. There is no significant difference in the mean of 3 groups, right? That means all the means are similar. Yes or no?
Yes, ma'am.
Yes, ma'am. Yes,
But
ma'am.
when I talk about H1, that is alternative hypothesis. So in this way, in this generally we are saying at least. At least one group mean is at least one group, no, one pair. I think this is the better way of writing. Done?
Yes, ma'am.
So the meaning is that what we are saying, at least one pair of groups have different mean. Means if in any of the pair, suppose there are three groups, group 1, 2, and 3. So maybe if group 1 and group 2, we are finding, or ANOVA is finding, the significant difference is coming. So this way, it will directly tell you that your p-value is less than 0.05 or less than your level of significance. That means you will say there is a significant difference. But meaning is that it is only telling you that in only one group the mean is differing, at least, not confirmed. You can maybe you need to check whether in first group and second group, second and third, and first and third, in all the three combinations the mean is differing or not. This is you cannot ascertain using the results of ANOVA. So this is the limitation of the ANOVA. ANOVA is only telling you, means wherever ANOVA is finding in these two groups the significant mean difference is existing, it will tell you you should go with the alternative hypothesis. Getting my point? Any doubt? Yes. Is it clear?
Yes, ma'am.
Fine. So this way we can say this is the limitation of ANOVA, and if we want to overcome this thing, usually in Excel it is difficult to do this. It is not possible for you to do this thing in the Excel. So you need to take the help of some other software. So there are tools or tests like multiple comparison, or you can call it as post-hoc. So using this test, if you want to see further in which pairs that significant difference is existing, that you can explore. But ANOVA only will ascertain you that at least in one pair of groups that significant difference is existing. I hope it is clear.
Yes, ma'am.
Shall I proceed? Hello.
Yes, ma'am.
Audible, right? Now, I hope you people have downloaded the sheet I have provided you on WhatsApp group.
Yes, ma'am.
You download it, open the sheet with the name One Way. Done?
Yes, ma'am.
Okay, so now you can see if everyone has opened it. Now I'm discussing the problem given in this sheet. We are having three different groups available here. Group 1, Group 2, Group 3, or tape supplier 1, tape supplier 2, tape supplier 3. And the strength of the tapes means whatever tapes we are taking from the supplier 1. So for example, total data is 30. Yeah. So 30 observations we are having. So means supplier 1, whatever the tapes we are taking, for at least 30 samples we have taken, and we have seen the strength of the tapes. So these are the values mentioned. These are indicating the strength of the tapes. So, for supplier 1, 2, and 3, all these three, or in all these three, from all these three suppliers, whatever tapes we are taking, we have measured the strength and we have mentioned in this particular table. Now, according to, if I want to compare, me suppose my purpose is to compare the mean strength, right, of the tapes. So here you can see firstly the variables given to us. First one is the strength of the tapes, which is the, I hope you can understand how many variables are given. Anyone who can tell me how many variables are given in this particular problem? I think I explained to you the problem. Yes, how many variables?
3, ma'am.
Three variables. Okay, can you name, ma'am?
Tape supplier 1, tape
I
supplier
want
2,
to
tape supplier.
Okay. Okay. What about others? Everyone is agreeing with ma'am. I think it was Rama ma'am, right?
Yes, ma'am.
Yeah. Everyone is agreeing with ma'am.
Yes, ma'am.
Okay. No other point of view? Fine. So, okay, I need to tell you this. Sorry.
Strength of the tapes.
Yeah, that is also given.
Yes.
So Pushpa ma'am, do you want to say something?
No, I think strength of the tapes will be the dependent variable.
And total how many variables?
Ma'am, I think
We have two variables,
Hmm.
the strength of the tapes and the suppliers.
30. Ma'am, 30 into 3.
Sorry ma'am, will you please repeat?
30 into 3, 90.
So 90 is what?
I'm not sure, ma'am. 90 data. No, sorry. 90. You told last time, ma'am, so you have it.
Okay, okay. Have you attended last sessions also?
Yes.
Okay, fine. Yeah, anyone else who will attempt how many variables? Yeah. Yes. Anyone?
Ma'am, is it 4, ma'am?
4?
We have only two variables and the suppliers have 3 categories because there are 3 suppliers.
So supplier and
Strength.
strength of that day. Fine. I think Pushpa, now you are correct. I will stop sharing my screen because I think I have only shared my Excel sheet that we would not be able to see my that data analysis toolpath. Now I'm sharing my entire screen. It's visible.
Yes, ma'am.
Yeah. Okay. So Pushpa ma'am said very correctly, we are having 2 variables only. The strength of the tapes and the supplier or the type of supplier, right? So we can say strength of tape is my dependent variable or my numeric variable, and supplier type or type of supplier is my independent variable with the 3 groups, right? Clear?
Yes, ma'am. Clear.
And for one-way ANOVA, we need only these 2 variables. So the condition is sufficient. That means variables are sufficient here for performing one-way ANOVA. Second thing, purpose is, as I already told you, my purpose is I want to compare the mean strength of the tapes, which I'm obtaining from the 3 different suppliers, right? So I will write here. So if you are not much comfortable in all these things, I'm requesting you to please write strength of tape is your DV, your numeric variable, and type of supplier is your independent variable. Done. Now, writing the null hypothesis. Anyone who will try? What will be my null hypothesis in this case? Purpose I told you, variables I told you. Yes, anyone?
There is no significant difference between the mean of the strength of the tapes corresponding to the 3 suppliers.
Is it fine?
Yes, ma'am.
Alternatively, I can say there is a significant difference in the mean tape strength obtained from 3 suppliers. I think obtained spelling I have not written correctly. It is OPTA. There is some problem with my system today. I think it's not working properly. So I hope please don't mind. Obtained spelling I have maybe mistakenly.
Okay, ma'am. It's
Yeah,
okay.
it's PAIND, right? So you make it correct at your end. Now, hypothesis is clear, variables are clear, data is given. So means now we can go and perform the one-way ANOVA. So requesting you go to the data tab, click on analysis toolpack, and you need to see, I think it is quite visible as tests are alphabetically listed. So ANOVA is starting from A. So you can find it at the first position. You can see ANOVA single factors. Factor meaning is independent variable. I already told you here we are having only one independent variable. That's why we will go with the single factor ANOVA. Here, select this, click on OK. So shall I click on OK?
Yes, ma'am.
Yeah. So the dialog box will appear like this. You need to select the data. So I have selected my data, including the labels or including the headings of my columns. So my range is coming as A2:C32. I hope it is same in your case also, because I think same sheet I have provided you. Right? Everyone selected the data range? Yeah. Everyone? Have you selected it?
Yes, ma'am.
Shall I go ahead?
Ma'am,
Yes,
today
ma'am.
I didn't get the data analysis, ma'am.
Sorry, ma'am.
I didn't get the data analysis.
Under the data tab, under the data menu, you can find, I think.
Last time I got, this time I didn't get it.
I think yesterday you performed or not?
Yes, ma'am, I was getting it. Okay, ma'am, you continue, ma'am.
Yeah. Now, second section is telling you your data is grouped by. So by default option is columns. And you can see I have provided you data in the column only. Group 1, group 2, group 3. Possibilities, because it is Excel, your data can be in the row also, right? But I think our data is in the column. So we will go with the by default option, which is columns. Fine. And understood why I'm going with the columns?
Yes.
Ma'am.
Now I'll select the labels in the first row because I selected my data including these headings. Requesting, if you have not selected these headings, do not check this box, right? Then alpha by default 5%. If you wish, you can come in the dialog box, come this particular box and make changes in the label of significance value. So I'll go with this. I'm not making any changes. I'll come to this and I'll give the blank cell reference here to get my output. Then shall I go ahead? Everyone, may I click on OK now?
Yes, ma'am.
Everyone is getting the output. Shall I